Find the worksheet that I've attached that has a coordinate plane and a circle on it, where the y-axis is called height. It looks like this. I have a lot written on here. Just make sure it's the one that says height here. The other one says base. We'll talk about shortly. What we're going to graph here is the sine function. To be a function, we need an input and an output. We'll use our circle to find our inputs and outputs. For the sine function, what we want to know is how far off the ground each seat is. So we will be finding height. That is our output. The input, what we need to know to find height, would be the angle of rotation that your seat is located at. So maybe your seat has rotated all the way to 60 degrees. Your seat would be located right here on the circle. Your height would be this side of the triangle. All right? So we are going to find this height for all the seats around the circle. Your paper is blank. Please copy the sine function, that the input is angle, the output is height for that angle of rotation. And you do not need to write this. Let me show you the following. For 15-degree rotation, the height is this length. The base of the triangle is this side, and then the radius is this side. I mentioned earlier the radius of the right is 100 feet. However, for this worksheet, the height doesn't say 100, it says 1. So the radius for this worksheet is 1. All you would have to do to know the height of the ride for any given seat is multiply our answer by 100, and you'll get the actual height of the seat for the ride. That means that this circle has a radius of 1. That's called a unit circle because the radius is 1 unit. That's all this means. Please note, we will be working with unit circle a lot this unit. Make sure the radius is 1 or you're not working with the unit circle. As long as the radius is 1, you are working with a unit circle. All right, so let's look at the 15-degree seat. It's so many feet above the ground, right? If this was feet and this was 100 feet, maybe 20 feet or so. I do know the answer is written right there. We'll talk about that in a minute. Anyway, I want to know this height. So I say, okay, for this triangle here, I need to know that the angle is located at the origin always. So the opposite side would be this side called height, and the hypotenuse would be called radius. So the sine of 15 degrees is going to be whatever that height is divided by the radius, which is, 1. So sine of 15 degrees equals height over 1. Well, dividing by 1 doesn't change anything. So really, sine of 15 degrees will equal the height of that seat. Now you may use your cell phone or a scientific calculator, graphing calculator, or Google to calculate this. Make sure that that calculator, whichever one you're using, is in degree mode. The Google calculator, when I tried the other day, was in radian mode. So I had to find the button that said RAD, and then right next to it said DEG for degree, and I had to push the button that said degree. If it's your own calculator, it's probably in degrees. Just make sure you get the same answers that I do, or figure out how to switch the mode. All I'm going to do is type 15 degrees sine, enter, or sine 15 degrees, enter, depending on your calculator, and you should get 0.26. Which means for our screamer ride, if I times that by 100, this seat is about 26 feet off the ground. So for an input of 15 degrees, the output is 0.26. I'm going to go over onto my unit circle. Each tick mark is 15 degrees all the way from 0 to 360. The seat is on the ground at 0 degrees, so go ahead and start at the origin. And then at a 15-degree rotation, the y value is about 0.26. Notice that the height is 1. If this is halfway to the height, then this would be 0.5. So 0.26 would be about halfway between 0 and 0.5. And as I get heights around the circle, I'm going to plot, given the angle, the output as my height. Please note that I would like you to pause the video in just a moment, Add the angles all the way around, if you haven't done that already. Notice that you add 15 to each angle. So 75 plus 15 would be 90 degrees. And I know they write the angle outside the circle, but because I also need to write the output there, I'm going to write the angles inside the circle the rest of the way around. 90 plus 15 is 105 degrees, and I'm going to continue all the way around. Make sure when you get back to here, you end up at 360 degrees. Okay? Go ahead, pause the video, and write the angles all the way around, and then keep finding the different sines. Sine of 30 degrees, enter, will give you the height for this seat. Sine of 45 degrees, enter, will give you the height of this seat, and continue all the way around. Pause the video now and continue once you have angles and decimals for the heights all the way around the circle. Okay, at this time, I assume that you have this. Focus. Yes. So, and here, if it helps, you can highlight one triangle. I just wanted to emphasize here, height is this side, and that we're doing the same computation for different seats all the way around the circle. So there's a ton of triangles that we've created. As long as you understand the idea, you don't need to draw all the triangles. Drawing one, I think, is good enough. I got the height is 0.26 here, 0.5 here, 0.71 here, 0.87 here, 0.97 here, and 1. And then I'll show you the graph in a minute. I do want to point out one thing about this graph before we do anything else, and that's the following. I'm going to go back to the screamer ride. Notice that when you get on the ride, the height is 0 feet above the ground, and in a 15-degree rotation, you rise that high. Notice at, say, 60 degrees, to get to 70 degrees, you rise that high. This is less of a height difference than this one. So when you're close to the x-axis, the y value increases fast. As you get close to the highest point, or the y-axis, then the change in the y value is very small. So we don't have a constant change of height. It's changing. It's getting, the height difference is decreasing as we go up to the highest point, and then just reversing down this way. Again, these two seats have the same height, so I would expect the same decimal for those two answers. And indeed, that is what I found. These two seats are the same height. These two seats are the same height. These two seats are the same height, etc. Now you may have noticed you got negative numbers below the x-axis, and that's because our height is below ground. So this seat is about 26 feet below ground. The negative indicates that. But these two seats are the same distance above the ground. These two seats are, these two seats are, these two seats are, and these two seats are. And then these two seats are the same distance from the ground, one in the positive direction and one in the negative direction. So you should have gotten -1 there. Right? And I realized I did not write the angles all the way around, but I did for cosine. So, and you can rewind back to the screamer ride to compare angles. So what I'd like you to do now is to check your sine graph. Pause at this time, and remember, for a height of a 15-degree rotation, the height was 0.26. So 15 degrees, 0.26. 30 degrees, 0.5. So the second tick mark, go up to 0.5. Third tick mark, go up to 0.71. Here's the third one, up to about there. And then I want you to plot all the points for every input and output all the way around, and then connect the dots. Pause now, please, and do that. All right, welcome back. Here is what I got when I did this earlier. Notice I even added more decimals on the side just to help me plot more carefully. That's what I get for the sine graph. Please note, input again is your angle of rotation. Think of your seat on a Ferris wheel or our screamer ride, and the output is the height of the seat. Also note that this ride could go around 2 times, or 3 times, or 5 times. With that in mind, every time I get to this spot here, I'm 26 feet above the ground. So if I rotate all the way around, my angle of rotation is 360 degrees, plus 15 more would be a rotation of 375 degrees, but the height is still that 0.26 because I'm at the same spot I had been at before. I say that because this sine graph continues. 375 degrees has the same height that 15 degrees had, so then the graph will go up and then continue down. The other direction, when the angles are negative, what that means is rotating the other direction. I'll say more about that in a later lesson. But negative angles, then I'm going to get the sine function going this way. What I want you to get out of today is to understand that the connection between the unit circle and the sine function, and to understand that this graph continues forever and makes that basic shape. And then as far as the practice goes, to use this graph to approximate different answers or outputs. For instance, and I'm going to use a different paper, but you